Tutorial question 1. A common method used in manufacturing sodium hypochlorite bleach is by the reaction this. So chlorine gas is bubbled through an aqueous solution of sodium hydroxide, after which the desired product is separated from the sodium chloride. So this is an undesired product and this is our desired product. A water NaOH solution that contains 1,145 pounds of pure NaOH is reacted with 851 pounds of gaseous chlorine. The NaOCl form weighs 618 pounds. So we will look at the question one by one later on. But first, we will have to put in the information into a table. So this is our reaction and the molecular mass or the molar mass for each component. For the stoichiometric ratio, we'll look at the value in front here. For the reactants, it is negative. For the product, it is positive. So since there's nothing here, meaning to say it is 1. So the stoichiometric ratio is -1. This one is -2, and this is +1, +1, +1. The question has given us that the initial amount of chlorine gas was 851 pounds. This one was 1,145 pounds. If we convert it into number of moles, which is by dividing with the molecular weight, we will get 12 pound mole. Over here we will get 28.6 pound mole. We were also told that NaOCl about 618 pound of NaOCl was formed, which is equivalent to 8.3 pound mole. So for part A, what was the limiting reactant? To find the limiting reactant, we will need to calculate for the extent of reaction at the maximum. With that, we calculate the extent of reaction at maximum for chlorine and both NaOH. Equal to NCl2 out minus NCl2 in divided by its stoichiometric ratio. And Cl2 out, there's nothing here, so this is 0, minus whatever goes in, Cl2 in is 12, divided by the stoichiometric ratio is -1. Therefore, we have 12 pound mole reacting. This is for part A. Then, calculate for the extent of reaction at maximum for NaOH. Similarly, the number of moles out, we have nothing here, so it's 0, minus the number of moles of NaOH in is 28.6 pound mole, divided by the stoichiometric ratio, which is -2, and we get 14.3 pound mole reacting. So the one with the lower maximum extent of reaction is your limiting reactant, because so this is your excess reactant. Therefore, Cl2 is limiting reactant. For part B, what was the percentage excess of the excess reactant used? So first, we need to find the amount of NaOH that is in excess. So ideally, the amount of NaOH required is based on the limiting reactant, which is Cl2. So 1 mole of Cl2 requires 2 moles of NaOH. Therefore, the NaOH required is 2 times of the number of moles of chlorine gas. It's 2 times 12 pound mole, which is 24 pound mole. Therefore, the excess NaOH is, we have a total of 28.6 pound mole of NaOH that was given, but we only require 24 pound mole, so we have 4.6 pound mole of excess NaOH. So calculate the percentage of excess. Percent excess NaOH is equal to the amount in excess over the actual required amount for the reaction, which is 4.6 over 24 times 100. You should get 19.3%. Part C. What is the degree of completion of the reaction expressed as the moles of NaOCl formed to the moles of NaOCl that would have formed if the reaction had gone to completion? So from part A, we know that the limiting reactant was Cl2. So in this case, we would have to refer to Cl2 if Cl2 has gone to completion. The NaOCl form is 8.3 pound mole, whereas if Cl2 were to complete the reaction, it would take 12 pound mole. Since the stoichiometric of Cl2 and NaO is the same, which is 1, therefore this is part C. Degree of completion is equal to 8.3 pound mole over 12 pound mole, which gives us 0.692. Part D. What is the yield of NaOCl per amount of chlorine used on a weight basis? So the yield of NaOCl, so our NaOCl form was 618 pounds, and per amount of Cl2 used, 851 pounds of Cl2 was used. So this is pretty straightforward. Part D, NaOCl yield is actually equal to 618 pounds over 851 pounds, which therefore gives you 0.726. Finally, for part E, what was the extent of reaction? So for the extent of reaction, we have to look at the desired product, because only then we know to what extent does the reaction goes through. The extent of reaction, same formula, N out minus N in over its stoichiometric ratio. In this case, number of moles of NaOCl out was 8.3 pound mole minus there's no NaOCl coming in, so it is 0, divided by its stoichiometric ratio, which is 1, positive 1, and the extent of reaction is 8.3 pound moles reacting.